It is physically impossible to insert a piece of 3/4-inch electrical metallic tubing, or EMT, inside a piece of 1/2-inch EMT without causing deformation to either or both conduits. This impossibility stems directly from the dimensional specifications of the EMT. The outer diameter of 3/4-inch EMT is approximately 1.55 inches. This measurement defines the overall width of the 3/4-inch conduit. Conversely, the inner diameter of 1/2-inch EMT is approximately 0.622 inches. This measurement defines the usable space within the 1/2-inch conduit. Comparing these two measurements, it becomes clear that the 1.55-inch outer diameter of the 3/4-inch EMT significantly exceeds the 0.622-inch inner diameter of the 1/2-inch EMT. This dimensional discrepancy makes physical insertion impossible without altering the shape of either conduit. Attempting to force the 3/4-inch EMT into the 1/2-inch EMT would require compressing the 3/4-inch EMT, expanding the 1/2-inch EMT, or both. Such forceful manipulation would undoubtedly result in deformation, compromising the structural integrity and protective function of the conduit. EMT conduit is designed to provide a rigid, protective pathway for electrical conductors. Deformation of the conduit can create sharp edges or constrictions that can damage wire insulation during installation or over time due to vibration or thermal expansion. Furthermore, deformed conduit may not properly seal at connections, increasing the risk of moisture ingress and corrosion, which can lead to electrical faults and potential hazards. The National Electrical Code, or NEC, sets forth standards for the proper installation and use of electrical conduit. These standards are designed to ensure electrical safety and prevent fire hazards. Attempting to force mismatched conduit sizes together would violate NEC guidelines, as it would compromise the integrity of the raceway system. Proper conduit sizing is crucial for ensuring adequate space for conductors. The NEC specifies maximum conduit fill ratios, which limit the percentage of the conduit's cross-sectional area that can be occupied by conductors. These fill ratios are in place to prevent overheating of conductors due to restricted airflow and to facilitate easy wire pulling during installation and maintenance. Using deformed conduit can alter the effective cross-sectional area, potentially leading to violations of these fill requirements. Moreover, forcing a larger conduit into a smaller one can damage the threads or couplings, creating a weak point in the raceway system. A compromised connection can lead to loosening over time, increasing the risk of electrical arcing and potential fire hazards. In practical electrical installations, it is essential to adhere to established conduit sizing practices. When transitioning between different conduit sizes, appropriate reducing couplings or adapters should be used. These fittings are designed to provide a secure and code-compliant connection between different conduit sizes without compromising the integrity of the raceway system. Firstly, always consult the NEC and local electrical codes to ensure compliance with all applicable regulations. Secondly, use properly sized conduit and fittings for the specific application. Thirdly, avoid forcing mismatched conduit sizes together, as this can damage the conduit and create safety hazards. Fourthly, inspect conduit runs regularly to ensure that they are free from damage and properly supported. Fifthly, when in doubt, consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable requirements. The selection of appropriate conduit sizes and fittings is a fundamental aspect of electrical installation. Understanding the physical limitations of different conduit sizes, then adhering to established codes and practices are essential for ensuring a safe and reliable electrical system. Remember that the inner diameter of the conduit is the space available for wires, and the outer diameter is how big the physical material of the conduit is, which is what you will use for things like conduit straps.